Hi all the students. Today we are going to study walk, path and circuit in a graph. What is a walk? A walk is defined as a finite alternating sequence of vertices and edges beginning and ending with vertices such that each edge is incident with the vertices preceding and following it. That means it is such an alternating sequence where you have a vertex, then an edge, then a vertex, then an edge, and so on. And this alternating sequence always begins with a vertex and ends with a vertex. Also, each edge, there is an edge between two vertices in such a sequence, and the edge between two vertices is such that that particular edge is incident on those two vertices. Also, the rule is that in this alternating sequence of vertices and edges, no edge can appear more than once in a walk. So, no edge will be repeated in a walk. However, a vertex can be repeated in a walk. Let's understand the walk with an example. Here you can see a graph which has 5 vertices. 1, 2, 3, 4, 5. And it has 1, 2, 3, 4, 5, 6, 7, 8 edges. So basically there are total 5 vertices and 8 edges over here. Out of these 5 edges and 8 vertices, there are few vertices and edges that contribute to a walk in this graph. So the red dashed lines represent a walk here in this graph. So you can see the red dashed lines, that means it starts with vertex V1, then edge A, then vertex V2, then edge B, vertex V3, edge C, then again vertex V3, then edge D, then vertex V4, then edge E, vertex V2, edge F, and vertex V5. So this is the alternating sequence of the vertices and edges that is shown by these red dotted lines. So it starts from here, goes here, then comes here, then goes down here, then goes here, and finally from here it comes down here. So this particular sequence of vertices and edges makes a walk. So as I said, it is an alternating sequence of vertices and edges. So you can clearly see vertex, edge, vertex, edge, vertex, edge, vertex, edge, vertex, edge, vertex, edge, and then a vertex. Also, it says that this sequence starts with a vertex and ends with a vertex. So you can say it starts with V1 and it ends with V5. Also, it says that no edge can be repeated in this sequence. So you see A, B, C, D, E, F. All the edges are unique edges, no edges repeated. Also, it says that though the vertex can be repeated or the vertices can be repeated. So here the vertex V3 is repeated in this walk once. Now this gives you a walk. So this alternating pair of vertices and edges gives you a walk in this graph, which is highlighted with the red dashed lines. Now this walk, basically there are two types of walks. When we talk of walks, there are two types of walks: open walk and closed walk. So when this is a walk we know, but this is an open walk. Why? Because the this walk starts with a different vertex and ends with a different vertex. So any such walk which starts with a different vertex and ends with a different vertex is called an open walk. So as you can see, this walk was starting with vertex V1 and is ending at vertex V5. So we can call it an open walk. So this is what this figure is representing, an open walk. So these red dashed lines here in this graph are representing a walk, which is an open walk. Otherwise, when the opening and ending vertices, that is the terminal vertices, are same, then the walk is known as the closed walk. So any such walk in which the terminal vertices are different is known as an open walk, and any such walk in which the terminal vertices are same is called the closed walk. And here, as we can see, that the terminal vertices are different, so this is an open walk. A walk is also referred to as an edge train or a chain. So that means the other names by which you can call a walk is edge train or a chain, though generally we call it by the name of walk. The set of vertices and edges constituting a given walk in a graph G is clearly a subgraph of G. Now you know that even a single vertex in a graph is called a subgraph of that graph. So it is quite obvious that the set of vertices and edges which constitute a walk in a graph is the subgraph of that particular graph. So clearly, as you can see, that these red dashed lines represent a walk of the graph, which is an open walk. So by rule, then this walk represents a subgraph of this actual graph. Vertices with which a walk begins and ends are called its terminal vertices. As I already told you, that the starting and ending vertices, that means the vertices with which a walk begins and then with which a walk ends, are known as the terminal vertices. Like in this case, you can clearly see that V1 and V5 are the terminal vertices of this walk, because V1 is the starting vertex and V5 is the ending vertex of this graph. It is possible for a walk to begin and end at the same vertex. It is possible that a walk begins with the same vertex and ends at the same vertex. Though here in this case, the walk is beginning and ending at different vertices. But it is possible in some cases that the walk begins and ends at the same vertex. Such a walk is called a closed walk. As I already told you, there are two types of walks: open walk and closed walk. Open walk is such a walk in which the beginning and ending vertex are different, as in this case, and in those cases where the walk begins and ends at the same vertex is called a closed walk. And then the opposite of closed walk would be an open walk. That means a walk that is not closed, that is the terminal vertices are distinct, is called an open walk, as in this case, as we have seen. After walk, now let's see what a path is. An open walk in which no vertex appears more than once is called a path. Now, as per the definition of walk, we say that the vertices can be repeated, but the edges cannot be repeated. Like here in this case, we saw that the vertex V3 was repeated once, but obviously no edge was repeated. Otherwise, it would not have been a walk. So in general, in a walk, we are allowed to have repeated vertices. But any such open walk, here we are not just talking about any walk, we are talking about an open walk. An open walk, that means a walk in which the terminal vertices are different. In such a walk, when no vertex appears more than once, that means in an open walk, when no vertex is repeated, then it is called a path. Now let's look at the example of a path in the same diagram. You can see these red highlighted lines represent a path over here. It starts with V1, then comes edge A, then comes vertex V2, then comes edge B, then comes vertex V3, then comes edge D, and then comes vertex V4. So obviously this is an alternating sequence of vertices and edges. Here you can see the terminal vertices are different. The first vertex is opening vertex is V1 and ending vertex is V4. So obviously, first of all, since this is an alternating sequence of vertices and edges where no edge is repeated, I can call it a walk. Then I can see that the terminal vertices, that is V1 and V4, are not repeated. So it is an open walk. Now, as per the rule, any such open walk in which no vertices are repeated is a path. So let's see if the vertices are being repeated: V1, V2, V3, V4. All vertices are unique in this walk. In this open walk, no vertex is repeated. So I can say that this is a path. So these red dashed lines represent a path here in this walk. Just by eliminating this self loop or the self loop edge in this walk, we got a path. Now, length of a path. The number of edges in a path is called the length of a path. Very simple. Whatever is the number of edges in that path, that would be called the length of that particular path. So here you can see there are how many edges? 1, 2 and 3. In this path there are total 3 edges, edge A, edge B and edge D. So I can say that the length of this path is 3. You must know one point, that self loop can be included in a walk but not in a path. So it is very mandatory for a path to not have a self loop, though there can be a self loop in a walk. This is clearly shown in both our examples. Here you can see this is an open walk which has a self loop, and since it has a self loop, the vertex V3 is repeated once. But when we removed this self loop from this open walk, vertex V3 was not repeated and we got a path. So a self loop can be included in a walk but not in a path. Now let's look at circuit, a closed walk. Now circuit is also made up of a path, of a walk just like a path, but a circuit is made up of a closed walk. So there are 2 points that you need to know, that a path is made up of an open walk. So whenever we study path, we study open walk, and a circuit is made up of a closed walk. So whenever we study circuit, we study closed walk. So a circuit is a closed walk in which no vertex except the initial and final vertex appears more than once is called a circuit. So again, circuit is also such a walk in which no vertex except the initial and final vertex appear more than once. Now, why are we allowing the initial and final vertex to appear more than once? Because obviously it is a closed walk. And as I said, in a closed walk, the terminal vertices, in a closed walk, the terminal vertices are same. So the opening vertex and the ending vertex have to be same, only then it can be called a closed walk. So in case of circuit, we are considering a closed walk, and the condition is that no vertex can be repeated. But since it is a closed walk, so we have to allow the initial and final vertex to appear more than once. Other than that, no vertex can be repeated more than once. So the circuit and path are similar in the sense that both of them are derived from a walk, and both of them do not allow vertices to be repeated. The only difference is that path consists of a open walk, hence no vertex is repeated at all, and circuit consists of a closed walk, hence you cannot avoid repeating the terminal vertices. Now here in this example of we can see the circuit. So the same graph we have considered, and the red dashed lines here represent the circuit. How? We start with vertex V2, then move on to edge B, then vertex V3, then edge D, and then then we go to vertex V4, then edge E, and then finally to vertex V2. So clearly we can see it is an alternating sequence of vertices and edges, V2, B, V3, D, V4, E, V2. So obviously first of all, I can call it a walk. This is a walk. But then I see that the terminal vertices, that the initial vertex and the final vertex are same. So that means this is a closed walk. Now since it is a walk and then a closed walk, so I have chances of finding a circuit here. Now let's see if it makes a circuit or not. I said that in a circuit no vertex can be repeated except the initial and final vertex. So obviously since it is a closed walk, the initial and final vertex have to be repeated. Let's see if any other vertex in between is being repeated. In between we have vertex V3 and V4. So no other vertex except the terminal vertices are being repeated here. So we can say that this is a circuit. Because it is a walk, then it is a closed walk, and then no vertex other than the initial and final vertex is being repeated. So I can say that this alternating sequence of edges which constitute a walk and which is a closed walk can be called as a circuit here. The other names by which you can call a circuit is a cycle, an elementary cycle, circular path and a polygon, but the most commonly used name is a circuit.